Okay, so in this case here, we got to figure out how to change the shape of this to this shape, and then also move it into this place. Okay, so what's going to be much easier to do is work out the shape first, and then move it into the right spot. Or in other words, do the compression, expansion, and flips first, and then do the shifts last. Generally, shifts last are easier. They're easier to do, they're easier to keep track of. So we're going to do that with horizontal and vertical first, but then we also have to remember we're going to put it in function notation, so the horizontal has to be done backwards for the notation. So first things first, we got to figure out how to change the shape. So vertically, what happened to the shape of this? Okay, did it flip? Okay, is it going from an M to a W? Yeah, it flipped. So we're going to worry about that, the shape and flip first. So I'm going to do a negative and flip it. Okay, what about the shape of it, the vertical length of it? I count from top to bottom. I count 1, 2, 3, 4, 5, 6, 7, 8. Here I count 8, 16 from top to bottom. It's definitely been stretched. Okay, so I'm going to flip it and stretch it. So now I've got the right shape. Okay, this right shape vertically at least. Okay, I'm going to worry about my horizontal and vertical separately. I've got the right shape vertically. Now I just got to figure out how do I shift it into place? And the point that I'm going to use is this point here. Now you can use basically any point to keep track of, but that point's easy to find on the new graph. It ends at 0. So I need to be able to flip it, expand it. So this is y equals 2. It's going to be times by negative 2. So I'm going to end up at negative 4. But it needs to be moved back up to 0 because that's where it ends up. So right now, if I do this transformation, y is at negative 4. So I'm going to do the shift last to move it into the right spot. And now I don't have to worry about shape or anything shifting anymore because the shape has been determined. Once the shape is determined, I can just move a reference point back into the right spot. So there it is. So I've chosen that spot there. I did my transformation. I moved it into the final place where it rests at y equals 0. And I can double check my points here. It's going to be 2 times negative 2 plus 4. Yeah, it's going to give me to 0. Okay, what about the horizontal? Okay, so same thing. I want to figure out what my transformation of shape is first, and then move it into the right spot. So here, I have something that is 14 wide, and it goes to 7 wide. I've horizontally compressed this by 2. Okay, the flip, well, since it's symmetrical, I don't need to worry about it. I could put a flip in if I really wanted to, but since it's symmetrical, I don't need to worry about the flip. So I need to first of all compress it by 2. Okay, and what happens when I compress it by 2? Everything gets squeezed to the x-axis. Now I'm going to still use that point here as my reference because now I have the right shape. I have the right horizontal shape. I just now have to move that spot into the right horizontal position. It ends up at 1, 2, 3, 4, 4.5. So I'm going to then move it to the left 4.5. Okay, so there is my transformation. This is my do part of it. I don't need to do anything backwards because I'm actually moving the coordinates in this way. Compressing, doesn't move that point. It's at x equals 0 still. Move it left 4.5. It ends up in the right spot. Okay, my transformation is done. I want to put it into function notation though. This is where the backwards happens. I now have to undo this calculation to put it into function notation. Okay, so my notation then is going to look like this. I'm going to times by 2 first. So I'm going to end up with x to the n, and then I'm going to add 9 after. Okay, so I could have done added 4.5 and times by 2 last if I wanted to. However, I'm just going to do it like this. I'm going to do my expansion, my shift first, and then compression last. Okay, here I actually described it slightly differently, but this is exactly the same algebraically. Okay, you may not have chosen this, but this is perfectly fine. This is the same algebraically as if I had written it like this. Okay, those are equivalent. So I'm just going to use that one just for the sake of argument. Okay, so now I can write it in function notation. So y equals, my y equals -2 times my f of x. Okay, here's my original f of x, whatever that graph was. And then on the outside of that, I'm going to do plus 4. On the inside, I want to use the notation form. I want to use that one. So I'm going to use 2x plus 9, and that's my function notation. Okay, and like I said, if you want to do the factored form and put it there, the factored form where we compressed first, then shifted last, okay, you can use that form, but these are equivalent, so either one would be fine. Okay, so what about this? We start with a pre-transformed function, and we're going to transform into another transform function. Now, it's probably easiest to maybe just keep the x's inside, and outside the outside. Okay, so how do we do this? So the outside actually kind of is not too bad, because I know that to go from here to here, I'm going to worry about the shape first and then worry about the shift after. Okay, so I'm going to worry about the shape first. So I know that it had to flip to go from here to here, it had to flip and expand by 2, or sorry, expand by 3. So the change in y is going to look like this. I know I have to times by -3 times my f of x, or my old y. Okay, so that's going to give me the correct outside coefficient. Okay, so go from here to here, I times by -3. But the problem is now my plus 2 got multiplied by -3 as well. So now I'm at -6. Well, to get it to -7, I'm just going to minus one more. So if I look at what I actually did, so I'm going to leave that in there, -1. What I actually did was this. I have negative x minus 1 squared plus 2. Okay, so it's going to be -3 times negative is +3. -3 times +2 is -6. -1 gets me to the -7. Okay, so I worry about the shape first. Okay, and then I adjust my vertical position accordingly. So that's going to be at -6 minus 1 gives me my y transformation. Okay, so that's all good. So I'm going to go y equals -3 times f of x minus 1. Now, what's going to be a little bit harder now is that this is my new x over here. This is my old x. I actually need to calculate a new x to get back to this old x. So if I can kind of keep track of that, it helps out a little bit. Okay, because here's my change in x. This is what it looks like. This is my notation, by the way. The notation looks like this. Here's my new notation, and it needs to get back to this old notation. Well, if I want to do the transformation, I solve for the new x. That tells me exactly what how I transform this. So if I want to write what actually happened from old to new, I can solve for that. I get x plus 4 and then divide by 2. Okay, so if I add 4, divide by 2, I'm going from here to here. Okay, But really I want to know the function notation. So I'm actually going to solve for this other x. So this is my do. My function notation is actually going to look like this. I'm going to move that, go +1, and solve for this old x. This actually represents my transformation of function notation. So this is 2x minus 4. And what I actually did was I moved it 4 to the right first, compressed by 2, and I'm going to end up with this same graph here. Now this is a little bit hard to understand, but if you've been following how I keep track of the old x and new x, and which one's the notation and which one's the description, this should make sense. Okay? So here, this is the new expression. This is my old expression, so that's why I have x new for this one, and this one is the old x here. Okay, this is going from old to new. So really, I want to know what can I plug into here to get me to here? Okay, or what can I go do here to get back to the old x? And this is what it looks like. If I want to plug this into here, I get that. Sorry, if I plug this into the f of x, I'm going to get this. So just better double check that. I'm going to apply the function notation. So if I do f of 2x minus 4, I'm just going to do the inside part. Okay, that's going to be negative. Okay, it's going to be 2x minus 4 minus 1. Okay, well, when I simplify that, I get 2x minus 5. Yep, that's the right function notation that I need to put into here to get me to the new notation here. Okay, so if you can, like I said before, if you can keep track of old and new, this should make sense. Okay, this be able to describe the transformation and also to be able to write the expression for the notation. It makes it a lot easier if you can kind of keep track of that old and new.